Hello everyone, welcome to ARC 319, Building Information Modeling. Please find a seat and settle in. Take a look at the person sitting next to you. In 5 years, both of you will be out in the professional world. But here is the reality. The one who understands how to manage building data will be leading the project, while the one who only knows how to draw pretty pictures will be working for them. Today, we aren't just learning a new software, we're learning a new way of thinking. I want you to clear your minds of everything you know about AutoCAD or manual drafting for a moment. We are moving from the era of drawing into the era of digital prototyping. 1. The great misconception. Revit is not BIM. Let's start by correcting a major error I see in many Nigerian architectural firms. You see a firm's portfolio and they say, "We do BIM," but when you look at their workflow, they're just using Revit to make 3D views for a client presentation. Revit is a tool. BIM is a process. If I give you a high-end surgical scalpel, does that make you a surgeon? No, it makes you a person with a sharp knife. Similarly, having a BIM software license doesn't mean you are practicing BIM. Building information modeling is the process of generating and managing digital representations of physical and functional characteristics of places. The key word is information. In traditional CAD, computer-aided design, if I draw a circle, the computer sees a set of coordinates, x, y, and a radius, r. It has no idea that circle is a column. In BIM, that object knows it is a grade 3 reinforced concrete column. It knows its cost per cubic meter, its fire rating, and its manufacturer. When we talk about the nature of BIM, we are talking about a database that happens to have a 3D interface. 2. The ontological shift. From lines to objects. In your previous years, you've spent a lot of time thinking about lines. You draw 2 parallel lines to represent a wall. In your mind, it's a wall. In the computer's mind, it's just 2 lines. In BIM, we use parametric objects. What does parametric mean? It means the object is defined by parameters or rules. If I place a wall object in a BIM environment, it is governed by rules. 1. It must have a base level, e.g. ground floor. 2. It must have a top constraint, e.g. first floor. 3. It has a thickness and a material composition. If I change the height of the ground floor, the wall stretches automatically. This is bidirectional associativity. It means that a change anywhere is a change everywhere. If you delete a window in an elevation, it is automatically deleted in the floor plan and the door-window schedule. This solves the uncoordinated drawing nightmare that has plagued Nigerian architects for decades, where the plan says one thing and the section says another. 3. The BIM maturity levels. Where do we stand? Now, as your professor, I need you to understand the global landscape of this technology. We use the Bew-Richards maturity map to see how advanced a project or a firm is. Level 0 is unmanaged CAD. This is 2D drafting. You're using a computer as a digital drafting board. Communication is via paper or basic PDFs. Most of the small-scale residential work in our local streets still happens here. It is inefficient, prone to error, and frankly, it is becoming obsolete. Level 1 is managed CAD. Here, you use 3D for concept, maybe SketchUp or Rhino, and 2D for documentation. But, and this is a big but, the 3D and 2D are not linked. You are still working in silos. Level 2 is collaborative BIM. This is what the world is demanding right now. In Level 2, the architect, the structural engineer, and the MEP mechanical, electrical, and plumbing engineer, all create their own 3D models. They then export these models into a common file format, usually IFC, Industry Foundation Classes. Then we perform federation. We overlay all the models on top of each other. This is where the magic happens. We can see, for example, that the structural engineer's beam is cutting through the architect's doorway. In the old days, we discovered this on the construction site in Lekki or Abuja. With BIM Level 2, we find it on the computer 6 months before the site is cleared. Level 3 is integrated BIM. This is the holy grail. Imagine a single model sitting in the cloud. The architect, the engineer, and the contractor all log in to the same file at the same time. There are no exports or imports. It is a live, breathing digital version of the building. We aren't quite there yet globally due to legal issues, who owns the model if it crashes, but that is the future you will be leading. 4. The dimensions of BIM. It's not just 3D. You'll hear people talk about 4D, 5D, and even 7D. Don't let the jargon intimidate you. These are just layers of information added to our 3D model. 3D, the model, the geometry, space, width, height, and depth. 4D, time or scheduling. We link the model to a construction schedule. You can literally press play and watch the building assemble itself over time. This is vital for managing complex logistics on tight sites. 5D, cost or estimation. In Nigeria, inflation is a reality. If the price of cement jumps by 20% overnight, a 5D BIM model can tell you exactly how that impacts the total project cost within minutes, because the software knows the exact volume of every concrete element. 6D, sustainability. We use the model to calculate energy consumption. How much solar gain is hitting the west facade of your building in Lagos? BIM will tell you. 7D, facility management. This is the handover. When the building is done, you give the client the model. If a light bulb burns out in 10 years, the facility manager clicks the light in the model and sees exactly what model number it is and where to buy it. SAN, the role of BIM in the construction industry. Why is the AEC industry so obsessed with BIM right now? Because our industry is traditionally fragmented. Think about a typical project. The client tells the architect what they want. The architect draws it. The architect tells the engineer. The engineer calculates. The engineer tells the contractor. The contractor tells the subcontractor. It's a game of telephone. By the time the message reaches the person actually laying the bricks, half the information is lost. BIM creates a single source of truth. Everyone looks at the same data. The MacLeamy curve. I want you to remember this name, Patrick MacLeamy. He proposed a famous curve that explains why BIM is so much better than CAD. In a traditional project, most of the effort happens during the documentation phase, when you are rushing to finish drawings. By then, if you find a mistake, it's very expensive to fix. BIM shifts the effort to the early design phase. We spend more time thinking and modeling up front. Yes, it's more work at the start, but because we are making decisions when the project is still digital, the cost of making a change is almost zero. 6. BIM in the design and construction phase. Let's talk about the practical reality of using state-of-the-art software. When we move into the lab for our 45 practical hours, we will focus on coordination. In the design phase, BIM allows us to perform clash detection. Hard clashes, a steel column is occupying the same space as a sewage pipe. Soft clashes, there isn't enough space for a maintenance worker to reach an electrical panel because a wall is too close. In Nigerian context, think about how many times you've seen a building being hacked on site. They break a finished slab because they forgot to leave a hole for the plumbing. That is a failure of coordination. That is a waste of money. In a BIM-driven project, hacking shouldn't exist. 7. Maintenance and operation, the 7D handover. Students, you need to understand that a building is an asset. For a client, the design is just the beginning. When we talk about BIM to maintenance, we are talking about asset management. Imagine you are designing a large hospital in Ibadan. That hospital has thousands of windows, doors, AC units, and medical gas outlets. If you use a BIM workflow, you can embed the user manual into the objects themselves. We use a format called COBE, or Construction Operations Building Information Exchange. It sounds technical, but it's basically just a smart spreadsheet that pulls data out of your Revit or ArchiCAD model. It tells the hospital's facility manager, this AC unit was installed on Jan 20, 2026. It needs a filter change every 6 months. Here is the phone number for the technician. This is how you provide value to your client. You aren't just giving them a building, you're giving them an instruction manual for that building. Sustainability and the role of research. We cannot talk about the future of Nigerian architecture without talking about sustainability. Our climate is demanding. With BIM, we can perform Building Performance Analysis, or BPA. Using state-of-the-art software, we can simulate 1. Sun path. How does the sun move across your site? Do you need those expensive glass curtain walls, or should you use shading devices? 2. Wind flow, or CFD. Can we use natural ventilation to cool a classroom in Enugu instead of relying on expensive, noisy generators? 3. Embodied carbon. How much CO2 was produced to manufacture the materials you chose? Industry experts and researchers are now using BIM to create circular economy models where we track materials so they can be reused when the building is eventually decommissioned. The historical perspective. Why did we need BIM? If you look back at the history of the construction industry, it has been plagued by 3 major issues. 1. Waste. About 30% of materials on a typical construction site end up in the bin. 2. Low productivity. While the manufacturing and IT industries have become 200% more productive over the last 50 years, construction productivity has actually declined or stayed flat. 3. Risk. Most projects finish late and over budget. BIM was developed as a direct response to these failures. It's the construction industry's version of digital manufacturing. Just as Boeing builds a plane digitally before they touch a piece of aluminum, we must build our buildings digitally before we pour a drop of concrete. A global and local perspective. The global drivers. In the UK, the government realized they were wasting billions on public projects, so they mandated BIM Level 2 for all government work. Now, if you want to design a school in London, you must use BIM. The same is happening in Singapore, the US, and Dubai. As a Nigerian student, why does this matter? Because the world is flat. You might be sitting in a studio in Akuru today, but tomorrow you could be working for a firm in Dubai or London remotely. If you don't know the international BIM standards, like ISO 19650, you won't be able to compete. The Nigerian context, the BIM Africa movement. Here at home, we have unique challenges. Power. BIM requires high-end computers. Constant power is a struggle. Data. BIM requires fast internet. Cost. Software licenses are expensive. However, the BIM Africa initiative and the Association of BIM Lagos are pushing hard to create local standards. We're seeing a leapfrog effect. Just as Africa skipped landline phones and went straight to mobile phones, many Nigerian firms are skipping advanced 2D CAD and going straight to BIM to attract international investors. If you want to work on projects like the Akah Atlantic City or major federal infrastructure, BIM is your entry ticket. The success and limitations of BIM. Let's be realistic. BIM is not a silver bullet. How BIM helps AEC succeed. Faster approval. In some countries, you can submit a BIM model for a building permit and a computer checks it against the code automatically. Visual communication. It's much easier to convince a client to spend money when they can walk through the building in virtual reality, linked to the BIM model. The limitations. GIGO, or garbage in, garbage out. If you put wrong information into the model will give you wrong results. If you model a wall as 200 millimeters, but it's actually 150 millimeters, your clash detection is useless. Legal liability. Who is responsible if the model has a mistake? The architect? The software company? The engineer? We are still figuring out the legal frameworks for shared models. The I in BIM. Most people focus on the M, modeling. The hardest part is actually the I, information management. Managing the data is much more difficult than drawing the 3D walls. Case studies. BIM in action. Think about the Museum of the Future in Dubai. It is one of the most complex buildings ever built. It would have been impossible to build without BIM. Every single panel was unique and had to be coordinated with the structural steel using complex algorithms linked to the BIM model. In Nigeria, look at some of the new bank headquarters or the remodeling of our major airports. The level of coordination required for the HVAC, or heating, ventilation, and air conditioning systems in those large spaces, can only be managed effectively through a federated BIM model. The future. Where are we going? We will discuss this in detail in Week 8, but for now, I want you to have a vision. The future of BIM is artificial intelligence and digital twins. Soon, your BIM software won't just wait for you to draw a wall. It will suggest the best position for that wall based on sunlight, wind, and cost. It will become a co-designer. We are also moving towards generative design, where you tell the computer, I need a building for 500 students with a budget of 500 million naira, and the BIM software generates 1,000 different options and tells you which one is the most efficient. Summary and next steps. So what have we learned today? 1. BIM is a process, not a software. It's about information. 2. We use parametric objects that have a database attached to them. 3. We operate in maturity levels, mostly aiming for level 2. 4. BIM covers the entire life cycle, especially the 80% of costs that occur after the building is finished. 5. In Nigeria, BIM is our tool for reducing waste, preventing building collapse through better coordination, and competing on a global stage. Your assignment for this week. I want you to download a BIM viewer like BIM Vision or Autodesk Viewer, or simply open Revit or Akah if you have it installed. I want you to look at a sample project. Don't look at the 3D view, look at the Properties palette. Click on a wall and look at the information listed there. Look at the thermal resistance, the volume, the area. Ask yourself, how could I use this data to make my design better? Closing thoughts. Architecture is no longer just an art of shapes, it is a science of data. As your professor, my goal is to make sure that when you graduate, you're not just an artist, but an architectural data scientist. In Week 2, we will go deeper into the historical issues, the specific mistakes the industry made in the past that led us to this digital revolution. We will look at why the old way failed and why there is no turning back. Any questions? No? Then I will see you in the practical session where we start our first BIM model. Talk to you later.